Hello everyone, today in this video we'll be discussing the third module of database, and today in this video we'll be having the three topics, which are SQL advanced queries and database application development. This is the most important one from this module, and the last one we have the internet application. Okay, the first and the last topics are very small, and the middle one is the most important one, which will be having the topics from which the questions are asked. Okay, so if you like this video, hit the like button and don't forget to subscribe to my channel. Okay, so let's get started with the first one, which is the SQL advanced queries. Here we will have the queries discussed, which are already discussed in the previous module in a more depth. Okay, so let's go through it quickly, and after that we'll be discussing the previous year questions which are asked in exam, which were asked in the exam. And let's get started with the first topic. In the SQL queries, first we need to know the null. Okay, null is used to represent the unknown, not applicable or unavailable data. Okay, and the in operator is used to select the data from the means whatever the data is in between the brackets. Okay, like for example, if you want to select the distinct ESSN from the works on table, and where the answer from this one is the domain. Okay, what I mean is, suppose that if I have to select the name of persons, if I use the in operator, if I mention 2 or 3 names here, if the name is present in the table among these names, then it will be selected. Okay, what happens is this operation will perform first, and whatever the data I get from here, from this data the selection will happen. Okay, the ESSN will be selected. Okay, that is known as the in operator. And the comparison operator can be used here. Like for example, first we'll select the salary from employee where department number is 5. So in the department number 5, who all are working, their salary is selected, and from that, wherever the salary is greater than the person selected in the department number 5, those will be selected. Okay, so that is used for the comparison operator. The next one is the exist operator. Exist is the same thing as the previous one, but here we'll have the 2 or more operations specified. Like for example, if I want to select the employee and the dependent who have the same gender and the same last name, what I'll be doing is I'll be writing this command here. In this I'll be selecting the gender and the name, whichever matches that will be selected if it exists, and from that I'll be selecting the e.fname and e.l name. So whoever employee have the same gender and the same name as the dependent, those will be selected, and I have to display just the first name and the last name of the employee. Therefore I will be selecting those 2 attributes. Okay, that is the exist operator. Okay, as we have previously discussed in the module, the join operation, aggregate functions like sum, count and average, and the grouping. And in this module also the same things are mentioned, so I didn't mention again here. For more information you can watch the previous modules video. There I have explained in detail. Okay, and moving on, we have the having clause. What does having do? By this example you'll understand. Select the attributes mentioned here and the count star from the table where the p number is equal to the p number of the table, and group by the p number and p name having count star greater than 2. So we will form groups here. Whichever group has the count star, means the number of rows in it greater than 2, that will be selected. Okay, so for that we will be using the having statement. By using having, we will be performing the operation with the aggregate functions like count star and all. Okay, or we can also use having for like having sum greater than 2, having average salary greater than 10,000 and so on. Okay, for that having clause is used. Now summarizing, we have the 6 main clauses: select, from, where, group by, having and order by. In this order you have to write down the clauses. Okay, whenever you are going to select some rows. Okay, and sometimes you have to check and select the rows, right? For that we'll be using assertion. It checks for the rows for the constraints. For example, create an assertion, then the assertion name, check where 10,000 is greater than or equal to the average salary or something. Then you have the select statements here. Okay, the check statement is nothing but the assertion. Okay, and trigger is nothing but if an assertion is true, what should be done, that is a trigger. Okay, for example, if the assertion is true, then update each row with new bonus is equal to new salary into 0.03, for example. Okay, if I have to increment the salary whenever I get the constraint as true, at that time I will be using this logic defined here. Okay, between begin and end, that is known as triggers. Assertion will check the value, means check for the constraint, and trigger will do some operation if the constraint is true. Okay, and views are nothing but a small part of the table. To create a view, we will use create view, then view name, and after that the select statement. Okay, Cascade means reflecting the changes in the two different tables. Suppose that I have two tables here and those two are connected by a foreign key. Okay, if I make some change here, that should be reflected back here. That is for that we will be using cascade, and restrict is used for the empty tables. Okay, if there is an empty table here which has no rows, that should be deleted, right, because it's of no use. So we'll be using restrict to delete the table. If it has some rows, it will not delete. Okay, and drop is used to delete the table or the database, and the alter is used to add some column. For example, if I have a table student here, if I want to add some column like roll number which is not present here, what I will be writing, alter table, table name, add column, the roll number, and I'll write int here because roll number is in integers. Okay, so that was about the first topic about the advanced queries. Most of them we already knew. And let's move to the main topic of the module, which is database application development. Here what we have is we'll be embedding the C, C++, and Java with SQL. Okay, because it's mostly needed for the interactive applications. Okay, so let's see what are the concepts mentioned here. So what is embedded SQL? The embedding of the C++ and Java with SQL. Okay, that is known as embedded SQL. And whenever we combine the C++ with SQL, we'll be using the variable names in the convention as C underscore then the variable name. Okay, to access them we'll be using colon. For example, if I have to access the variables passed in the arguments, I'll be using exec, that means execute, SQL insert into Sailor. Sailor is the table name, values. Instead of writing the manual values, what the user has passed in the argument, that I'll be using. For that I have to use double colon, because it's not the value which I'm inserting explicitly, is the value which is which the user has entered. Okay, in the variable C underscore S name. Okay, like that we'll be inserting the values by using the C programming language with SQL. Okay, and what is a cursor? It allows us to retrieve one row at a time. Suppose there is a database here, it has many rows. To retrieve one row at a time, I'll be using cursor. So it points to one row, outputs the whatever the data is present in that row, and after that it goes to the next row. Okay, here's an example. If you want to find the age and the name of the sailor, okay, sailor is a table, so what I have to select is s.sname and s.age. I'll be selecting from which table? Sailor S. Okay, where the SID is equal to CSID. See, this example I can explain you by using a web page. Okay, in the web page you got search bar here. Here it was showing like enter the sailor's ID for which you want to see the name and the age. So I'll be entering some ID here that will be stored in the C underscore SID. In this variable it will be stored. Now this variable will match with the database wherever the SID is stored. Okay, whichever row it matches, that will be printed. Okay, that's what we are doing here. The row, the variable CID is matched with the s.sid. So in the table s.sid, it will be matched whichever row matches with the CID, CSID, that will be selected, and what is selected from that table is s.sname and age. Okay, so that because that's what we are expected to find out in this question. Okay, so that is how you use the cursor statement. It's not just the retrieving of value, you can also update the value. Okay, for that you have to create a cursor here, like by using open, and before closing, before ending the program, you have to close the cursor. Okay, we'll fetch the sinfo into sname and ch. So whatever sinfo I get, I will be storing in the name and the age variable. Okay, and to update the values, we can use update sailor s, where set s rating is equal to s rating -1, where current of sinfo means wherever the current cursor is pointing to in the table, at that place update the s rating as s rating -1. So all those places, suppose that s rating is here, it will become s rating -1. Next, this row here also it will make the change, and so on till the end. Okay, and we can store some SQL statements in an array like CSQL string delete from sailors where rating is greater than 5. So this is a statement is saved, and we can execute this statement. Okay, like exec, then ready to go from SQL string. This is the SQL string here, and then we'll be executing the function. Okay, so this will save us the time of writing the statement again and again. Okay, the next one is the Java database connectivity. In the previous topic we discussed about the C and C++. Now we'll be discussing about Java. Okay, how to implement Java with SQL. Okay, 4 things you need to know: application, device manager, drivers, and data sources. What are each of these? Application is the user interface which you see when you open a browser, that initiates the terminates the transactions and the boundaries of the connection. And the next one is the device manager. Think of it as a compiler. Okay, it loads the function calls, initializes the variables, and logs into the system and checks for the errors, and after that it's all done, will be executing the program. By using drivers and data sources, we'll get the data and execute the program. These are the four main components of the Java database. There can be either the same platform in the DBMS or the different platform of the DBMS. For example, here is the DBMS 1 which is in the platform A, and in other platform there is DBMS B. To make a connection between A and B, we can use the different type of bridges. If they are of different platform, use type 1. If they are of same platform, use type 2. If you want to access the data in a faster manner, use the type 3. Else we will be using the sockets. Okay, sockets to establish the connection if they are in the remote locations. Okay, that is for type 4. And JDBC classes are the collection of the Java classes and interfaces for connecting and executing the SQL statements. Okay, so there are few steps to be followed if you want to connect the Java with SQL. Firstly, you need to load a driver. This is the syntax for it. You will be specifying the URL of the driver. After that, make a connection. Store the URL in variable string here, and then make the connection by using the arguments as the URL, username and password. After the connection is established, you have to either write the command or get the or delete the commands. Okay, for writing you will use commit, and for deleting the commands already done, we will be using rollback. Okay, and to execute the statements, what is a statements? It's a SQL query. Okay, there are three types. The prepared statement, that means it's pre-compiled, and callable statement, it can be called from the main function. Okay, and result sets is used to display the output of the query. Okay, means after a query there will be results shown here. It acts like it acts like a cursor, but it's not a cursor. Why? Because in the cursor will be reading the data from the database, whereas in result set will be reading the output from the database. Okay, this for the input and this for the output. Okay, the syntax is as follows. We'll be creating rs object of the result set, and we'll be reading the title if you want to read the title output one by one. Okay, by using rs.next. Okay, and suppose that we made an error and we did not get to know where the error is. It's very hard, right? So to make sure that we get to know where the error actually is, we'll be using warning and exceptions. This is a syntax for it. We'll get the warning wherever we have committed the errors. Okay, there are 7 steps for achieving this one. The first step is to import the package. Okay, second step is to load the driver by using the syntax given here, and then establish the connection, create the statements, execute the statements, and process the result, like print out the result or store the result in some other database. Okay, after that don't forget to close the connection. Okay, and these all steps can be done in a more simpler manner by using the SQL Java, which is using the SQL iterator. Here you will have the arguments which you need, like a title and float price, and you will be creating a class here, books. Okay, inside that books, what is to be selected? Title and price. Okay, the book title and book price is selected by using colon here, and after that from which table? Books, and from where the author is the same as the author name. Okay, so by using this statement, all those book name will be selected, which will be stored as a string. Okay, once you have stored the database means the book names, what you will be doing is each time you will be printing one book. Okay, like book title and book price, then you will go to the next book. Okay, this seems pretty simple, right? Like store a result, and we can use repeatedly without writing again and again, right? So that is known as stored procedure. Okay, you can create a stored procedure as follows. By using this syntax, the procedure name here and which variable you are using, specify here. Between begin and end, store your procedure. For example, here the procedure is to count the number of students who have the name as Akshay. Okay, and print the count. Okay, so whenever you want to execute, instead of writing this, you can just use ss to execute the statements. Okay, how you will do that? By using the call statements. Okay, call statements, and write a name here, and then whatever string you want to execute in the SQL query, store that in CSTMT or any other name. Okay, after that the final result will be stored in rs, which will be printed one by one. Okay, how you will execute is using the name which you have used here, dot execute query. Okay, this is how you call a stored procedure. And SQL is a procedure oriented programming language. For example, if you go through this, you will understand what is actually procedure oriented programming language. Here we have the create function. This is the syntax. Rate customer, these are the arguments, and here we have the what it returns. It returns an integer, and for declaring we will be using the keyword declare. This is the syntax for it, and the variable name followed by the data type. Okay, and what is the operation you need to perform? Select count star from orders where the TID is equal to customer ID. Okay, and we have the if else statement. Based on that, we will get the final value for rating, which will be returning at the end. Okay, so till this point, if you understood what all I have told, that should be sufficient for you for externals most probably, because that's what they have asked in the previous year questions. And let's move on to the next one, which is the internet applications. Here we have the three types of architecture, which are single tier, two tier, and three tier. What are the main features of it? In the single tier, we have the DBMS queries and the functions and the transactions in a single space. Okay, and everyone cannot access this one, only it can be accessed by the database administrator. Okay, here's the diagram. Here we have the client, application logic, and DBMS. This all is stored in a single platform. Okay, and two-tier architecture, there are two types, the thin client and thick client. In thin client, what we have is the client comes and accesses the DBMS and the SQL queries defined initially. Okay, and in the thick client, what happens is only the DBMS is here, and the client should come with their own defined SQL queries. Okay, that is the main difference. And in the two-tier architecture, we have the client and server. Okay, in three-tier architecture, we have the three layers, which are the client program, application logic, and data storage. These are the languages used, which we'll be discussing in the upcoming topics. And for now, just understand what are the main features of each layer. In the first layer, what we have is the user interactions. Like when you open the web browser, whatever you see is the client program layer. Okay, after that, we have the application layer, where all the logic is defined of what are the transactions to be implemented, and here we have the retrieval and storing of the data. Okay, let's discuss what are the technologies used in the three-tier architecture. The first one is the HTML forms. Whenever you open Google, you'll be seeing some results here, right? That is the HTML forms. Yeah, it has four main things: action, form name, get, and post. Okay, method has two types: get and post. Action is what is to be performed, form name is the name of the form, and the get and post is to get the data or store the data. Okay, and the next one is JavaScript. To implement the JavaScript in the HTML form, we'll be using the script tag along with the source tag. Okay, so by using the JavaScript file name, you will be able to implement the features of JavaScript, means backend features, in the HTML forms. Okay, after that, to change the outlook, you will be using CSS and XSL, and by using CGI, common gateway interface, you will be accessing the data. Okay, it's not like you'll just give the command to the server and they will be accessed directly. They have to pass through common gateway interface. Okay, then they will be able to access. And servlets are mini servers for each of the web page. Java server web pages are used to build dynamic platform independent web apps using APIs. Okay, and to maintain the state, you will be using some protocols like HTTP, and after that we have the cookies which store the user info. Okay, and coming to advantages of the three-tier architecture, it can be used in different platforms, and it only needs some computation power, very few. And integrated data means if the data is present at different locations, the system should be able to access the data without losing any of it. Okay, and it's scalable because the multi-users can access the data, and it's easy to compile, run, and debug. Okay, because the whole architecture is divided into three parts, and each can be if an error happens, we can easily know where actually the error has happened, right? So it's easy to compile, run, and debug. Okay, so these are all the main things what you need to know in this module. Let's discuss the previous year questions. From the previous year questions, the first question is about the view, which we have already discussed, and the next one is consider a schema for the company database. They have the tables employee, department, delocation, project, and works on. Okay, and what we are supposed to do is we have to write the queries for the following. Okay, here the query is to list all the project numbers for the project that involve the employee whose last name is Scott as either a worker or a manager of the department. Okay, so what you have to do is you have to do two queries. The first one is you will be selecting those employees who are as a worker and the last name is Scott. Second is who are a manager and work as a and the last name is Scott. After that, do the union operation. Okay, and the second one is show the resulting salaries if the every employee in the working IoT project is given a 10% raise. Okay, what you have to show? The salaries. So select salaries from the not salaries, you have to give a 10% raise. Select means multiply the 10% with the salary and display the result from the table name and where the project is IoT. Okay, and find the sum of the salaries by using the sum you can find, and the minimum, maximum, and the average that can also be find by the aggregate functions like sum, average, min, max, and by using the group functions to group the people according to the department. Okay, and retrieve the name of each employee who works on the projects controlled by the department number 5, okay, by using not exist operator, okay. So what we have to do, first we have to see which all employees work on the project 5 by using the exist operator, and then from that who work on all the project controlled by that department, that we have to print out. So select a name from the employee where exist from the select statement, again the department number is equal to 5, there you will get the final result, okay. The next one is for each department that has more than 5 employees, so count star is greater than 5, retrieve the department number, so select department number and the number of its employees who are making more than 600,000, so the salary is greater than 600,000, that you have to specify, okay. The next one is about the sorted procedure. We have discussed 3-tier architecture and nested queries and the assertions, aggregated functions and the assertions and triggers, and a program to write SQL program to create an assertion to specify the constraint that the salary of an employee must not be greater than the salary of the department. Okay, so here what you have to do, you have to specify a constraint like the salary of the employee should not be greater than the salary of the department. So by using a check and create assertion, that I have discussed in the theory, okay, that exact syntax, okay. But the main thing you have to do is check if the salary of the employee is greater than the department. If it is true, then reject it, okay, else accept it, okay. In the next question we have been asked to define the following, that's discussed in the theory, and write the complete high level language program to display the rows of the customer table created using Oracle. This has 3 attributes: customer ID, customer name and balance. Now how you'll do that is, first you'll write a normal program, okay, like the Java program. After that you'll specify the string to select star, okay. You'll write like string is equal to select star from the whatever table you have created, the customer, and that's it. You have to store this in a string here, and after that establish a driver means establish a driver connection means what you have to do is, you have to create a driver and then make the connection. How you will create a driver is, you have to specify the URL and along with the driver keyword, and then you will make the connection by using the connection object. And after you have done the connection, the initialization of the driver and the connection, and after that what you have to do is, you have to execute the query. The query is stored in the string, then you will do that string name dot execute query, and then after that you have to print the statement and close the connection, okay. In that way you can define your own Java and C++ program. The next one is about the different types of architecture and the SQL commands and the variables, and write a program to explain the how to retrieve the tuples in the embedded SQL, okay. To retrieve the tuple, first the same things what I have mentioned before only, that's the same thing. Establish a driver connection and execute the SQL query. Before that you have to save the SQL query, and after that print the results and close the connection, okay. That's how you retrieve the tuples in a embedded SQL, okay. So that's all for the video, and thank you for watching. I'll see you in the next one.